Today we shall be looking at the acing your coding technical interview. So we're just picking up a problem in binary trees, and let's pick this problem, and we want to solve it within the time of a typical interview. So it's 15 minutes. So we start that. So let's see what we can do within 15 minutes. So given the root of a binary tree, return the post order transversal of its nodes value. So post order transversal means that, let's see example. So we have this 1, 2, 3. So 1, no left. So 2, no, 2 as left, 3, and no right. So the output will be 3, 2, 1. Of course, null. 1 is 1. 1, 2 will be 2, 1. This is 2, 1. Number of nodes in the range is 0 to 100. The value is negative 100 to 100. Okay. So how do we do this in post order transversal? Essentially, post order means after we have gone to the left and gone to the right, then we now append the value to our list that we want to return. That's post order. So definitely we're going to be needing an helper function here that will help us do the post order so that we can return the result from our post order. Okay, but in an interview you want to quickly give 1 or 2 examples of yours so that you and the interviewer could clarify that. So you want to be like, okay, if I have, let me say I have 1 here, and I have 2, and I have 3. So what do you expect the post order of this to be? So the post order of this should actually be 2, 3, 1. Am I right? So let's see based on what we have here. So this is, so what this means is we first of all go to the left, we go to the right, then we go to the left, then there's nothing more, then we print this, then we backtrack and we go to the right, there's nothing more, then we print this, then we backtrack, we print 1. So for this, so we go to the left, okay, of this. So there's, once we get here, we want to go to the left, nothing more, go to the right, nothing more, then we print this 2, then we backtrack here, then we go to the right, then here we go to the left, nothing, we go to the right, nothing, then we print 3, then we have 2, 3, 1. So we want to clarify that. So one more example, let's say we have 1, 2, 3. Want to clarify this, what should it be? Okay, so we start from the root, we go to the left, there's nothing, then we go to the right, then we're here, then we go to the left, there's nothing, then we go to the right, then we're here, then we go to the left, there's nothing, go to the right, there's nothing, then we print 3, then we backtrack to 2, then we backtrack to 1. Okay, so this should be good enough for us as examples. So once we have finalized that with our interviewers, then we can now begin to code and see what we can do. So essentially we're going to be returning a result. So we're going to have a result which is going to be a list, and so we need an helper function. So we can define a post order helper function. So what that we do is going to take a node and help us define the post order. So essentially, if node is none, then we backtrack. So if there is node, then we go to the left, we go to the right, just like we said earlier. So we go to the left, that is the left of the node. So at this time we know the node exists, so we don't expect to run into error. Now go to the node dot right, and once we have done that, we append the results. So result dot append the node to our result. But then so that's we have the result and it's available in a function. So that's that. So we can now come in here and call our post order transversal. We'll call this. So we need to pass in this result here because it's not available in our function. So we need to pass this result. So we can call the post order helper on what we are given, which is the root. So we call it a root, and at the end of the day we return our result. So that should do it. So let's now walk through some basic example. If it is null, so if this is null, we come in here, this is null, okay? So it comes here, if not node is null, it returns, okay? At the end we just give result, so which is empty, that's correct. If it is 1, so root is 1, then we come in here and node is 1. If not node, so node is 1. We go to the left, so the left recursively and return. We go to the right recursively and return. Then it append 1 to this, and it has modified our result. Our result now has 1. Then by the time we return result, it's going to contain 1. That works. So let's see 1 and 2. So if our root is 1 and 2, so we come result is empty. Then it comes in here, our root is 1, and it calls if not node, node is 1, post order on the left, so it comes in here, left is what, 2. So at this point our node becomes 2. Then it recursively comes here, if not node is 2. Then it wants to call node dot left. At this point our node dot left is none because there's no node there. And it comes here, we see that it is none. Then it comes to the right. So what is the right of 2? That is also none. So the right of 2 is also none. Then the current node is 2, so it appends 2 to this. So our this is modified with 2. And it backtracks back to 1 because we are done with the left. It goes to the right, so it is none, and it returns and backtracks and add 1. So we have 2 1. Yeah. must say that recursion is very difficult to trace, but I'm sure you get the gist of that. So let's just run it now on the test example and see what it gives us. Oh, we have an error there. We didn't pass in the result. Supposed to pass in the result there too into our function. Yeah, and we need to carry that result all along. We need to carry that result all along into our function because we are calling it recursive. We have some error there. Let's see. We have 3, 2, but they want it to be int. So what we're supposed to append here is actually a var. So what we appended is just the object. Yeah, so we got it. So let's try some more input, and let's try this one. Let's see what it gives us. That also works. Let's try this as well. Okay, that also works, so we're good. Let's try this, and we're within time. We're well within time. See that? That works too. So almost all our test cases works. So let's see this one. Want to see this? Okay, so all those work. So let's go for all of them and see. Good. All right, so thank you very much, and see you in the next one. Bye.